Hey everyone, so I want to take a few minutes to go over the DeltaMath assignment on interpreting graphs. Just go over what the question's asking, how they want you to give the answer. Sometimes it shows the solution in a slightly different way than we did in class, but just to show you if you do it the way we did in class, that it'll also accept it and why they give that other way. So I think it's mainly the third and sixth topic that are going to give trouble, maybe the fourth, but let's go through each one just to make sure we're on the same page. So this one says finding roots. So roots are the same thing as zeros. We use zeros in class, but basically it's asking what value of x do you have to input to get an output of zero, right? So remember, if my point is giving me an output of zero, that means we're not going up or down. If my y-coordinate is zero, so we're on the x-axis. So it's basically asking for the x-intercepts. So for example, -8 will give me a zero because that's the point -8 comma zero. So if you're in the box and you type a comma, it'll automatically give you more to type in, but so you should realize that automatically. But just the point, you have plus and minus signs here, so if you want to add, like I notice here that they my pen tool got messed up. Uh, that there's three x-intercepts. So if you're gonna need three boxes, you can click on the plus sign, get three numbers, then you could type in the -8. That's just zero there, and then that's a six. So six will also give you an output of zero. Um, So that topic that shouldn't really cause an issue. For this topic, thing I want to just to point out is that the parentheses tell you what segment it's talking about. So if I see this is segment one, so this first sentence is talking about segment one. Then segment two is here, so this next sentence is talking about segment two. So for example, if I look at segment one, I see we're going always go from left to right, so we're going down the roller coaster hill. So that one is decreasing. Okay, and then remember, you always want to look at the left and the right. So where it starts. So this one, it starts at -9, and I'm going down the hill until I'm here. So this would be -4. Okay, so from -9 to um, -4. Remember, we don't use the equal sign, so you don't have to worry. It gives that automatically for you, but no equal sign for increasing, decreasing. So this is now talking about segment two. So segment two, we're going up the roller coaster hill. So we're -4 currently. That's where we stopped with the last segment. So from -4 all the way up, and I'm right here when I'm top of the hill. So top of the hill would be just one. Okay, so from -4 to one, we are increasing. And then this is talking about segment three. So I see segment three, we're going down the hill. So we're back to decreasing. Okay, so we left off at one. That's where we're at the top of the hill. So I go down until I'm at the end here. At the end is seven. So that'll be from one to seven. Okay, and if you get it wrong, you could see the color I think helps you. So it'll do down in red, up the hill in green. But you can see how they do the vertical line just to see, okay, look at the x coordinate where it starts going up and the x coordinate when it stops going up. All right, let me clear this pen. Okay, so this is one of the ones I want to talk about. So with these parabolas, if you remember from Algebra 1, um, so this one's asking where the function, let me grab my highlighter actually, is decreasing. Okay, so if I look at the parabola, I'm going always if I'm going from left to right, so if I come in from the left, right here I'm going down the hill. So this is decreasing, decreasing, decreasing until I'm at the bottom. And then once I'm at the bottom of the hill, then I start going up. All right, so this is increasing in green. So decreasing yellow, increasing green. Okay, so here I'm going down. So basically with these parabolas, um, the way Delta Math says or wants the answer is it sort of splits the parabola in half. Right, so on one side we're going down, one side we said we're going up. So it wants the decreasing one, so we care about this left side, so going down the hill. So if I split the parabola in half, this is an x coordinate of 2. Okay, so when your x is less than 2, so less than is this side of the graph, so this would be the decreasing side. And when x is more than 2, this is your increasing side. So if you did the way we did in class, like if I want this yellow piece, there is no left boundary. There's an arrow here. So that's just negative infinity if there's nothing on the left. And on the right side, we said 2 is where it stops. You're at the bottom of the hill. So you could type in negative infinity. Remember, no equal sign for. So you can always use the parentheses. So you could type in negative infinity and then 2, that's the way it did in class. It would accept that. Or you could just say when x is on the left side, so when x is less than 2. So when x is less than 2. So you don't really have to use infinity. You could just say when x is less than 2, that's the left-hand side, you're going down. And when x is more than 2, you're going up. So less than 2 would mean every value less than 2, so down to negative infinity. So we don't really need a lower boundary because less than 2 is all the negative numbers, right? So that's the answer, and you can see that's the answer it wants here. But if you do negative infinity to 2 with parentheses, it'll also accept that. Um, okay, so this one has parabolas as well. So this next topic says the other one I want to talk about. So um, let's. Okay, so for something like this one I think is straightforward. So it wants, remember when it's less than 0, that means negative. So from less than 0, negative. So negative means below the axis. So you want any piece that's below the axis. So left and right boundaries, -5 to -1. So this piece that's below. I think that's pretty straightforward. Let me do another one here. So yeah, so something like this, once again, if you sorry, trying to get my highlighter here. Okay, so it wants, once again, the negative less than 0. So negative would be anything below the axis. So you have this piece that's below and this piece that's below, right? Because that piece is above the axis. So once again, you could do, so this piece, there is no left boundary because arrows in negative infinity up to -5. Um, so if you did that, or and then this one, the left side is 3, and then the right side, there it goes down forever, so there's an arrow on the right, so 3 to infinity. Um, and there's an or button, so you could say like when x is less than -5, so everything on the left side, anything to the left of -5 over here, I'm always going down forever, and anything greater than 3. So or x is greater than 3, or if you want to do the intervals, like just parentheses. So if you did like negative infinity up to the -5. So everything up to -5, click the OR button, do another set of parentheses here. Okay, so or, so this piece, the left boundary is 3, the right boundary, there's an arrow, so infinity. So 3 to infinity, just to show you it would accept, this is what we did in class, it would accept this as well, even though it's looking for this. So, and if you do get it wrong, it color codes it. So when you're less than -5 or when you're greater than 3, you're always below the axis, forever in that direction, forever in this direction. So you could use the infinities, or with parabolas, you can just use the inequalities. Because if they don't give you an upper boundary, that means 3 to infinity, because every positive number more than 3 is would be included there. Um, Okay, this topic I think won't give any trouble, but just to show one, just to go through every one. All right, so it says from negative infinity to A. So A is here, and negative infinity would be the left side because there's an arrow here. So it's talking about this piece here. Okay, so we're going always from left to right. So going from left to right, we're going down the hill. So that's negative, and this piece is above the axis. So it's decreasing. Did I say negative? I'm sorry. So, yeah, I'm going down the roller coaster hill, so this is decreasing, but it is above the axis, so it is positive. Okay, so remember, this means going up or down, so we're going down the hill. So I could eliminate A and C, it's not increasing. And then it's above the axis, so positive. So I want positive, but decreasing. So that one's multiple choice. So look at each piece. This one has infinity on it, but usually it's like F to G. So you're looking at this piece here. So you're increasing since you're going up the hill, and you're below the axis there. So below the axis is negative. So the multiple choice I think will help there. Okay, last topic I want to talk about. I don't want to make this video too long, but I think this one is the trickiest of the bunch. So I want to look at a couple different scenarios. Um, okay, yeah, I think this is perfect for my first point. So, uh, sorry, I'm tired of the right. Okay, okay, so it's asking when it's decreasing. So going from left to right, we're looking for where the roller coaster is going down. So here, if I come in from the left, we're going up the hill, up the hill. So once I'm at the top of the hill, then we start going down. Okay, so we're going down, 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 down. Okay, and then we're going up the hill again. So this we're going up forever. So one thing I want to point out is decreasing means the y value is getting smaller and smaller. So if the graph flattens out like this, usually, um, let's see if I could zoom in here. You kind of tell it does get flat there. So at that point here, we're not decreasing, we're flat. We're just going straight. My slope is 0. Same thing here. If it does get flat, I would not include that in the increasing interval. But DeltaMath sort of ignores that flat piece. It just considers this entire piece going down. So once again, you always use parentheses. You never, no equal sign for increasing, decreasing. So if I look at this down piece, the left starts at -5 and it stops decreasing. The bottom of the hill is here. So that's going to be 2. Always X coordinates for functions because those are unique. Right? I can't give me a Y value 2 because if I'm at 2, I might be here. I'm up 2 over here. So it's not unique. So always X values. So um, it wants that piece and it will color code this, but you can see like it does include that flat piece, which is technically not decreasing. So um, same thing that would even include this in increasing, even though it gets flat. So it's not really going up at that point. So just to point that out. Okay, so it's not going to give it to me. So the only thing I want to point out is there were some questions where, like for this one, for example, it asks where the intervals where the function is greater than 0. So greater than 0 is positive, but it does include the equal sign here, so it doesn't want only above the x-axis. It points on the axis would want to be included as well. So if you're doing these intervals, you do want to use the equal sign if the point is on the axis. But the other thing, it will give you ones like it'll ask where the function is negative and the entire graph will be above the axis. So there'll be no piece that's below the axis, right? So if you don't have an answer like that, well, there is no answer you can give if the entire graph is above the axis and there is no negative piece. So if that's the case, um, if you don't have an answer, then you can literally give no answer. So just leave it blank and click submit, and um, they would accept it. Like if it asks when it's positive and this entire thing was below the axis, I would just click enter. There is no piece that's positive. Okay, so we'll do something like this. So increasing, just to finish off on this one. So coming in from the left, I want where the graph is going up. So we're going up the hill, up the hill, up the hill here. Okay, then we're going down the hill, down, 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 down. Then once I'm at the bottom, then I start going up again. So this piece has two parts that are increasing. Okay, so for the first part, so once again, if I do lower and upper boundary, there's an arrow on the left, so it's negative infinity, and it goes up till -6. Okay, so you could do negative infinity to -6, or you could just say when x is less than -6. So if you're less than -6, so anywhere over here, we're always going up, 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 up. So this is always going to be going up. So either way for that, then you can do the or. And then for this piece, at the bottom of the hill, I'm at 1. Get my pen here. Okay, so I'm here, I'm at 1, and then I'm going up the hill, up the hill, up the hill, up the hill until I'm at 5. Okay, so from 1 to 5, so once in parentheses, never use equal sign. All right, so 1, extra comma to 5. It should accept that, yeah. So that's what it wants. If you do negative infinity, -6, or two parentheses from parentheses, that's fine as well. Um, yes, I hope that made sense about the being let the positive, negative, and just spinning an empty answer. If you're lucky to get that one, because then you don't have to type anything. But yeah, so I hope this was helpful. Thanks for watching.